Hello, my name is Victoria Fliss, and today we will be learning about modeling the free body diagram. From the picture, we know that this is a 3D system. We can see that joints A, B, and C are journal bearings. From the course notes, we know that multiple journal bearings resist translation radial to the rod. This means that at A and B, the reaction force from the journal bearing in the E2 direction is 0, and that the unknown direction acts in the E1, E3 plane. Similarly, at C, the reaction force from the journal bearing in the E3 direction is 0, and the unknown direction acts in the E1, E2 plane. The magnitudes at A, B, and C are also unknown. The forces at D and E have known magnitudes and directions. We will use this information to create the free body diagram of the system. Our first step is to draw the entire bar. Don't forget that this is a 3D system, and your drawing should represent that. The next step is to model the support reactions. Recall that A, B, and C have unknown magnitudes and directions. We can represent this using a complete force vector. The notation with the bolded R and subscript A is used to represent an unknown magnitude and unknown direction at the support reaction. Similarly, we can draw a complete force vector at B. Recall that the unknown direction of the reaction at A and B is in the E1, E3 plane. The same complete force vector is drawn at C, keeping in mind that the unknown direction acts in the E1, E2 plane. Remember that the magnitudes at A, B, and C are unknown. Now we can model the forces at D and E. At joint E, there is a 600 Newton force in the positive E3 direction. To represent this, we draw a force vector, where the magnitude is italicized and the direction vector is bolded. In this case, F1 is equal to 600 newtons. Similarly, for the 400 Newton force at D, we can draw the force vector F2 in the positive E2. Once again, the magnitude is italicized and the direction vector is bolded. Finally, we can model the self-weight of the bars. Each of the 3 bars should have a unique typical particle. For this particle, the magnitude is mg dy, as we are finding the mass per unit length. The direction is in the negative E3. We can use the same notation for the other 2 bars. We now have our final free body diagram of the system.